Okay, welcome back, everybody. Yeah, Rohit's question about is this part about the marine space, is it only using 2D or geometries or also 3D geometries? I double checked in the standards, and actually it's also about 3D geometries. So there is a volume feature over there to define spaces. And so this schema is taken from the standard. So if we go up and make it a little bit smaller, you can actually see what the standard is about. And so this is this document, part 3, marine space georegulation. I have not exposed you directly to these standards documents. They're a bit special in their structure. But for the assignments tomorrow, you will be asked to have a look at these standards and also do something with it. And that is for tomorrow. So this was just a correction that also part 3 is about 3D geometries and 3D boundaries. So Rohit, thanks. It was indeed not in the lecture, and it was also not properly answered by me. Let's go to the lecture. So valuation, how do we record these values in a model that everybody understands what it means? Abdullah Kara investigated the thesaurus, the set of concepts defined by these various international organizations. Also, he sent out a questionnaire within FIG Commission 9, which is the commission which is about valuation, collected responses about the needs, and also studied, of course, the literature from the World Bank, FAO, and other organizations to capture all relevant information about semantics. And then he came up in his PhD research with this proposal, the valuation information model. The core class here is the VM valuation, and that defines what input data and output data is used to produce either the single or the mass appraisal values, and what method is used and how the values are computed. And for mass appraisal here, the specific information is documented, what method, statistical methods, what types of analysis is used. The valuation unit is where the actual value is attached to an object, a piece of land, a building, and here there is a relation, an indirect relation to a spatial unit. Valuation unit in Dutch is bosobject. Van de wet onroerende zaken, the law on the immovable property, bosobject or valuation unit. For example, it can be one-to-one mapped to spatial units when it's about normal ownership. But in case, for example, you are renting an apartment in a building, then there's one owner, but there are many valuation units, many apartments, many bosobjects also in the Netherlands. And so this relationship is is represented in the model. Valuation is often done per area, per region, and this can be indicated because, yeah, one of the sayings in valuation is, okay, what determines the value? That is first location, then location, and next location. And after that, they're looking at properties of the object. Okay, how many rooms do you have in your building, or how big is your garden? So therefore, this grouping in zones. Spatial unit is, say, the link to the LIDM spatial unit. Can be the complete spatial unit, complete parcel, but it can also be a part of it. For example, the front garden, the back garden, or the area where the building is located. Valuation is often related to buildings, so there is also a lot of attention to modeling buildings more in detail, either the complete building, the VM building, or the units, the condominium units in the building. Valuation, probably most important input is historical transaction prices. But okay, that was the history. And so how is this history developing? And that are the statistical models. And yeah, the collection of the transaction prices in sales statistics is often input for the valuation processes. And it can also be that next to all kinds of sales statistics, that you also include other characteristics, data sets about, say, topographic information, or site visits, valuation reports, that is also used. What LRDM is doing with the new valuation model is storing the information. So LRDM is not giving you the process, it's giving you a way to store the information so that somebody else can understand it. And so there are quite a number of classes, specific data types, and code lists, and yeah, based on earlier documentation. Yeah, one side step is that also here 3D is very relevant, as you can imagine. So the rights can be in 3D, like in a building. Yeah, what is important is also that you have a nice view in your property, and then yeah, you want to do a 3D view analysis, or also how the noise is propagating is depending on the 3D configuration. Hazards or explosions, toxic goods are propagating in 3D. 3D also has an impact on, okay, what is more prone to criminal victims. Sunlight, daylight computations, points of interest, how you can reach them, the distance in 3D is relevant. But okay, one example, that is the view in 3D, same building, this turquoise building here in the middle. The view from two floors are compared, both the front view and the back view. In yellow and orange, the view of what you can see from the top apartment. And if you go one level lower, then your view is limited. You can see less. You can only see the orange and the red. So there are some changes. Mainly you see less because you are lower. You cannot see so well over other objects. So for example, you cannot see this river over here. Well, the top floor can see the river because there are probably some elevations in the terrain or bushes that make you, that is blocking your view. And so this is, and you can imagine that this is kind of impacting your value. Okay, that was part 4 about valuation. Now going to part 5, spatial plan information. We already discussed a little bit, say, spatial plans before in the context of the public law restrictions, or restrictions they create. In reality, today, in I would say 99% of all the countries, the land registry, land administration, and the spatial planning authorities are very different organizations. They have different ways of working, they use different information. Sometimes there is some information exchange, but it is not a good match. So they have different conceptual models, and this really makes it hard to be used together. While it's so obvious that this information should belong together. So here we see a number of streets and one block with different use. So in yellow there is space for utilities, water, sewer system, electricity. So you should be able to access utilities for maintenance. Here are the parcels, the ownership parcels. Okay, most of the utilities are not in the private parcels. They are next to the road in the public parcels, but there are some underground utilities that are crossing also the private parcels. Here we have the actual buildings with the different functions. So commercial, shopping type of activity, housing, factory. And this is shown in 3D in this perspective view image. Okay, we can have a look at the spatial plan over here, and there's a distinction. Okay, one part is for the housing and the other part is for the commercial zones and for the shopping. Yeah, when we confront this together, when we bring this information together, we also make the spatial plans 3D. So to what height are you allowed to develop this activity? Okay, what is the offset from the road you have to take into account? And then you get these spaces or these envelopes. But you also see that some things are not correct. They're not fitting in the envelope. They are too large, or either sticking on the top or sticking to the sides, or they are also the wrong functionality. And so a factory in a residential area is not what you would like to see according to the zoning plan. So this is the well-known picture. So the theory is clear, and we need an extension where we include also the spatial plan information. This model was developed by Agun Indrait in his PhD research in Delft. He also explored what is already there. Is there already a standard which is similar? There were some hints, but not really standard at ISO level. At European level, there is the Inspire directive with the land use and the planned land use, which contains some good clues. And that was also used in the European Plan for All project. He distilled a number of key classes, plan unit, and he's using the SP prefix, which is the smallest area or space with a specific function assigned, like the residential or the commercial or the educational or the recreational activities. And this is usually depicted on the largest scale map with the highest detail. very similar to cadastral maps. Another important concept is the plan block, and that is, yeah, a group of plan units, neighboring plan units, that were, say, accepted, decided on by the authorities as a coherent plan for a certain area, a part of the city or part of the environment. And then these plans belong to a hierarchy of spatial plans, and where typically at the top, and there is the most generic plan, smallest scale map, but the intention is that the maps or the spatial plans below, with more detailed maps, should somehow comply with the intentions of the higher level plans. And so this is a typical planning hierarchy. So depicted over here in the slides, the planning group, it could be provincial plans or complete municipality plans or national plans, generalized maps, where you have a rough indication of, okay, what is the intention. This is hierarchical, so therefore there is an association and an aggregation association from plan group to the next level in the plan group. At a certain moment, we arrive at the level of the spatial plan block or city plan, zoning plan, where we have the highest detail. Within such a plan, we can find the planning units and the actual areas indicated with their function. Again, this is the research from Agun Indrait. There can be maintenance to the spatial plans. So therefore, there is this relationship between the spatial units. Can also be, this is temporal relationship. You cannot see it, but if you would dive into the documents describing the model, you will find this is the lineage, the temporal relation. And here we can have other relationships. Okay, when we have these spatial plans as, okay, legal information, what is allowed, what is not allowed, what is restricted. The next step is, okay, support spatial development. And that is also included a bit in this model by adding one more class, which is the permit. And the SP permit is an actual approval of the authority giving you the permission to do some development. Of course, it has to fit in the intended purpose of that area, of the zone in which you are falling, the plan unit. But okay, that is checked by the authorities before they give you this permit. So this is the model that was developed and now included as part number 5. And now, having all these parts together, and you could say that we really provide a complete land administration. And now also spatial planning is not something which is elsewhere disconnected, but really put together with the other rights and restrictions, private law, public law, also taking into account the third dimension about the elevation in the vertical direction, sometimes also horizontal distances and constraints. Agun also develops a nice prototype to get there. Here it is. This is in Indonesia. He developed it for 2 cities, Bandung and Jakarta, 2 big cities on Java. And you can hover over the areas and you can get an indication. So this dark red is residential high density. This green is natural preservation. Also click on one of these objects and then you can say more information also about the city and the actual zone in the city. If we hide the spatial plans and we see the actual buildings in this area, so in 3D, but similar to what we also have in the Netherlands with the 3D buildings. But if we then switch on the plans again, and we see that there are some mismatches, as you can expect, perhaps. But this is, yeah, really interesting, and by putting all the information together about the plans and the land use which is allowed and the actual use, we can find mismatches. The idea is that citizens would get this information on their computing device, maybe a mobile phone, maybe a laptop, and could also go outside and check, is what I see happening over there? Maybe it's a educational area or a residential area, but if a factory is then being built, they can check it themselves and report this back to the authorities, to the municipality. Because with the rapid developments ongoing, it's very hard for the government to check everything. And by also giving people the information, that they can help also protect themselves against, say, the developments which are not according to plan. Okay, you can also test it yourself. Because there are so many buildings, it takes a bit a while before the demo is started. So therefore I already started before. So be patient before all the data is downloaded. Okay, now we covered all parts of the conceptual model and we go to a special part, part number 6, which is the implementation. And yeah, we have seen the past 10 years quite a number of implementations. We've seen different tools being used, technical models, GML, Interlis, RDF, GeoJSON. We saw people, countries implementing processes, developing workflows. And these are all not now in LIDM, but it would be good also to have some support for future countries or industries or open source communities that want to produce software that is implementing land administration systems in the broad sense, and so including valuation, the marine environment, the spatial plans. We still have to work on this. It's certainly not ready. Maybe there is one part ready, and that is how to create a country profile. And so starting from the generic LIDM standards, how do you get to a specific country profile? And this paper cited here is also on Brightspace, and is also shortly explained next. A couple of weeks ago, I explained the scope of LIDM, which is still true. It has been extended, but it is a reference model. It is abstract, it's conceptual, and it's the basis for the national and the regional profiles. But okay, how do how do you create such a national profile? And yeah, by analyzing the reported and documented country profiles, which were about 40 by now, of which about 10 are in production, so implemented in countries as their operational system. We could somehow distill the following steps. And so first it was always about scoping and what is inside the model, who is responsible, and what are the stakeholders. When it's about renewal, also what is the new vision? Should the scope be extended? Should we add 3D descriptions? Should we include evaluation or not? Yeah, the last part of the scoping phase was analyzing the content of the current systems, the current land administration systems. And how to obtain this is by studying, meetings, interviews with the stakeholders. And there is some feedback loop. If there is a different vision than what's actually in the current system, okay, then there is a need for improvements. And this is then discussed with the stakeholders. Okay, then based on this scoping information and vision, you could say the actual first country profile is created. And so the mapping of what is in the existing systems is mapped to LIDM classes. Then a UML model is created, UML class diagram. But very important is also the code list and populating the code list with values. And checking at the end if the proposed model is conforming the specified conformance test, and they are in Annex A of the current LIDM standards. And so if you find something which is not conformant, you should correct it in the UML model and improve it. Also extends the code list values when something is missing. Again, this model should be presented to the stakeholders to see if they agree. It's covering their needs. Maybe they are disagreeing, things that they don't want or things that are missing. After this, say, more paper or theoretic exercise, the next step is to somehow test the model. So do an implementation, develop a prototype, collect real-world data, and maybe harvest it from the existing systems, convert it. Look at typical examples of registration. It was given in week 3. So remember all the slides with the examples of how to register things. Okay, how would that fit in this newly proposed country profile? If you are still happy about the country profile, then do creation of a database schema, load the data you collected, and develop a user interface to visualize the data. And if your vision is to support 3D, then you should have also 3D visualization. And the database and the XML schemas can be directly derived from the UML models created earlier. So you could say this could be the initial model of a country profile, but over time new wishes may arrive, and then from this current country profile, we see that quite often A second profile, country profile, is developed for the same country, extending the original one. That was also the case in the presentation of Abdullah Alatas 2 weeks ago, when he said, okay, initially and currently we only have a 2D registration, but he made this proposal for the future, where also in 3D the rights in buildings were modeled and documented for the future. And that system could then be used as we have a more mature land administration system, more complete. Okay, here more in detail the phases. Okay, who are typically the stakeholders, the mapping agencies, the governments, governmental organizations, the industry, the academic community, typically involved. When it's the first model, and then, okay, have a look at the current situation in the year restriction about the legislation, what should be included. If it's about improving the model, think, okay, and what is the wider scope, what is added, maybe take advantage of the new parts of LRDM that are developed, valuation, spatial planning, or marine. And together with the stakeholders, analyze the national legislation. If you have ambitions that need it also to change your legislation, okay, and then you have to start also working on that. Collect the documentation of the existing systems. So this is the more detailed explanation of the overview given before. Maybe also include, say, building models, and this work is typically done in iteration. So this is the second phase. What are the mappings of what is in a country already there? And remember, this mapping is not trivial. You have to do with language issues. So LRDM has been translated into a number of different languages, from English to French to Russian to Croatian. And certainly not in all languages of the world. And so it's also a thing to consider, that is mapping. Then creating the model. And the model is the start for the model-driven architecture. If in LRDM there are classes missing, so these classes are there in the national systems, then they have to be added also in the country profile, and somehow related to the other classes. And existing LRDM classes can be extended, for example, with new attributes that are not in LRDM but that are needed. And so this is actually conceptual design at the national level. And these are typically the things you do, inheriting from LRDM core classes and create a new class with the prefix of the country profile, for example, Netherlands, NL party, or NL special needs. In the last assignment for tomorrow, which will also be introduced tomorrow, you will be the developer of a country profile. So you may pick your country, but you have to do these steps. You have to make sure that what you develop is fitting within the national regulations. You also have to figure out, okay, who are these stakeholders? When you develop the model, in the end, you should somehow assess it, test it, and with the Annex A of LRDM, the test is given. Okay, after you created the model or somebody creates the model, I'm now talking about you because it's also the assignment of the model, but this is what countries are doing in day-to-day activities is collect the data, test the model, create instance level diagrams. How does it work? It also helps in explanation, see what is stored where, and then in the end develop a actual system. First a prototype system, select a database, Postgres or Oracle with a spatial extension, PostGIS, and create your country profile and develop a user interface to work with the data, to edit or to query, and to visualize the data. And quite often nowadays, this is done via web tools, 3D web tools. Okay, that's it for part 6. I must say that this is the part where still most of the work has to be done. Okay, all parts have to go through this quite long process of ISO, all these steps. So they all need work, but say part 6 needs the most work. And so we are most far with part 1. We are now at the this status. For part 2, we created the working draft, we received the comments, and we are planning to have meetings with the members of the project team to discuss how to process the comments. Part 3 was distributed in January, and we are now waiting for the comments. Part 4 and 5 are also ready in working draft version, have not been distributed by ISO, but that will happen before the summer. So part 4 end of this month, so very soon, and part 5 somewhere in May. And for part 6, as said, we are still working on creating good content here for the standard. How to get from the conceptual models to the technical models to the encodings. Are there also processes that can be standardized at international level? It was already difficult for the information, but what about the processes? Are there similarities between the countries? And okay, one part that is ready is this approach or methodology for country profiles. Okay, this is basically where we are now today. Hopefully in 3 years from now, 3-4 years, all these new parts are ready. But tomorrow, assignment number 4 starts, and you can choose on which of the parts you will focus. And so you will develop for one country the basic land registration, but you will also be asked to add one of the new parts to that country's profile. So either the marine part or the valuation part or the spatial plan part. And I will put the ISO documents online to get an impression. And the part you select, you should study carefully. That's it. Thanks for your attention. I think it is a good time also to stop. On Brightspace, I've also added a number of slides how things work with, say, less formal rights. And so what was mentioned before with the continuum of rights, how it works with group rights. There are some example models. So I would first like to ask, are there any questions now about the new parts? No? Okay. Okay, in that case, we do have time also to go over the additional slides with the customary rights. Okay, these slides are made also by Crit Lemon. He has been working yeah, a lot in various developing countries, Africa, Latin America, Asia. In the bottom you see our little town that was used before, a water river. And in the town everything was neatly organized with say, more formal rights, apartments. But in the surrounding areas there are yeah, less formal settlements, say informal settlements by groups of people. We have the Gracie Basin, which has number WG 1A and 1B, 1A on this side of the road and 1B at the other side of the road. We have a second informal property, WG2, Grassy Woods. We have another property, WG3, which is also two parts, one in the grasslands and one in the forest. And then we have a fourth property with informal boundaries, not that sharp. So how does this look in the model? Okay, first, okay, how to model the parties that have this say, informal or customary rights on the communal lands. So either it can be modeled as a group party with a number of members. And, yeah, there can be many members and they are all identified member by member. Can also be the case that we do not list all the members, but representative persons for groups. And so if the community is consisting of a number of families, then every family has one representative which is recorded in this group party. Or it could be that it is not defined at all and that we just have, say, one party where it is not really explicit who are the members, but typically then the chief parties are used as contact persons, and also deciding in case of changes what is happening. So what about this grassy basin? Has two parts. It's not per se very well surveyed boundaries. These two parts, spatial units, are one administrative unit where there's this ownership right, informal ownership right attached to this community, the grassy basin community, and with their members. Okay, or it could be with their representative persons, the elderly persons. Okay, looking at the spatial representation, there are some boundaries which are quite well represented with coordinates measured and surveyed, and other boundaries are not fixed. So here we see a mix of what was called before the general boundaries and the fixed boundary approach. And together they give the complete boundary of the region. And the last part of modeling this informal situation is, okay, attaching the rights, figuring out what are the rules and who is allowed to do what, and what are the grazing rights, who is allowed to pick firewood, or fruits from the plants, and what is the process, and what are the roles in these processes. There's one chief often of such a community, say the mayor in a formal city, and there are elderly, say family heads that are being represented, and maybe in the Dutch system or Western system, the representatives in the council, in the city council, but also what is the right of the woman when holding the land and using the land. Okay, it's not my area of expertise, but I hope it gives you a bit of an impression. And I noticed chat moment. Okay, then this was it for now, for today. Yeah, you now have a complete overview of the new version of LRDM. Tomorrow we start the new assignment, but tomorrow I hope we also have a guest lecture of Abdullah Kara, explaining how he developed the valuation information model. He will also give an example of how he applied it in Turkey to develop a country profile for Turkey, and how he made also a 3D extension to this Turkish country profile with valuation. Any questions? Last opportunity. If not, then I wish you a good lunch, and see you tomorrow again online, unfortunately, for the assignment number 4. And of course, do not forget to submit assignment number 3. Okay, bye. Have a good day. Bye-bye.
Bye. Bye.